This is going to be a very brief video lecture on circles, just a conceptual approach to what a circle is. And I know that most people, actually everybody knows what a circle is, right? It's a round object, that type of thing. We're going to go through the official conceptual definition of what a circle is. But before we do, we have to have one prerequisite, just one. You have to know how to graph. So here's the conceptual definition of a circle. It's just a set of all points that are equidistant. That means they're equal distance from some fixed point. And that fixed point we call the center. And that equal distance that they're all away from that center is called the radius of the circle. So pretend for a moment that this is a perfect circle. Can't say that it is. I'm not 100% sure. Kind of looks like it to me. But this is actually a set of all points that share one thing in common. They're all the same distance from that center. So if I take any point along here, those points, the distance between them and that fixed point will be the same. So this distance, which we'll call r, is the same as this distance, which we'll call r, which will be the same as this distance right here, which we'll go ahead and call r. That's the official definition, official conceptual definition of a circle. Now, this is all that we would have to this lecture if I wanted to stop here. But actually, I think there's something else I should introduce you to, just so that you know this for your future development in mathematics. It turns out a circle is called a conic section. So maybe I should write it down. It's a type of conic section, in fact. So, what does that mean? What does it mean that a circle is a conic section? Well, let's take a look. What you see before you right now is from the Wolfram Alphas project, or I'm sorry, Wolfram Demonstrations project, right up at the top here. I don't know if you can see that, but it says Wolfram Demonstrations project. You can Google that if you want. It has a ton of little demos that you kind of play with, but this is the double cone. Or, well, this is where the word conic comes from. It's because you consider two cones that are kind of point to point, and take a sheet of paper that'll slice through those cones. Now, if I grab this and I look straight down, you see that picture on the inside? That's a circle, isn't it? It doesn't necessarily have to be a circle, because what if I were to move that sheet of paper, I don't know, through an angle, like that angle right there? So notice that the sheet of paper is tilted. When I re-look at this, it's not so much a circle anymore, it's changed its shape. Maybe it's not so obvious yet. Maybe I'll tilt it a little bit more so you can easily see it. Now when I look, it's not a circle. That's what's called an ellipse. That's another type of conic section. It's a section of this cone. That's why they call it a conic section. So a circle is a conic section. This ellipse is a conic section. And it turns out that if we keep going, like maybe to here, I don't know if that'll be perfect, but let's see. Keep going. You see another shape that's very familiar that is also considered a conic section. This is a parabola. A parabola is also considered a conic section. It's very, very neat. Now, if I keep tilting that piece of paper, look, it starts slicing through both of them. And if you look at that, it's like two parabolas, isn't it? But it looks a little steeper than a parabola. It looks more V-shaped. Turns out that is called a hyperbola. Okay, so when you have those two edges, it's called a hyperbola. So we have four objects that can be created from a piece of paper slicing through a double cone. We have what's known as a hyperbola. We have what's known as a parabola. We have what's known as an ellipse. And finally, the regular old circle. Alright, so that's just a brief conceptual intro to a conic section, but it's very important that you know that that's not what we're focusing on here, but it is going to be something you're going to focus on in the future.